All right, if you had any questions with your homework on page 58 where you had selected odds from 1 through 81, I decided I wouldn't explain every single one of these homework problems because I really don't think that you actually probably need step-by-step instructions. So I just worked out anything that actually needed work here. So I'm just going to kind of page through the homework slowly, and then you can adjust the video to your own needs. I would like to talk a little bit about 43 and 47. In our notes, we discussed a long way and a short way to do number 43 and 47. These are called binomial squareds, and we'll see these later on in Algebra 2 and other math classes. And it's really going to be to your benefit to be able to start to learn the shortcut here. And it's up to you on Friday's quiz whether you do it the long way or the short way. But later on in this class and other math classes, it's really going to help you to know the shortcut. So the long way is on the left, and you're just foiling those out. But let's use 43. I'll kind of walk you through this one. So 2x plus 3 squared. Remember, that means 2x plus 3 times itself 2 times. So you can just FOIL that out. That would be considered the long way. Or the shortcut is square, double, square. So you take the first term, which is 2x, and you square that. You'll really do this in your head. I've tried to write the steps out, but you'll actually do this line of work that I'm pointing to right here. You'll actually do this whole line in your head. So you'll do 2x squared, and you'll write down 4x squared. The sign in the binomial is a plus, so put a plus. Then you're going to multiply the two terms together in your head. So 2x times 3 is 6x, and you're going to double that. So you see that right here in my work. You're going to double 6x. So 2 times 6x is 12x. And then you're going to square the last term. 3 squared is 9. So that'll be plus 9. So 4x squared plus 12x plus 9. Again, I'll explain 47, the shortcut. You take the first term, 4x squared, you square that. 4x squared squared is 16x to the fourth. You take the sign of your binomial, which is minus. You write a minus. You multiply the two terms together. You double that. That gives you negative 8x squared. And then you square the last term. Negative 1 squared is positive 1. In 51, we have a binomial cubed. We talked about this in our notes. Most people do not memorize the shortcut for the binomial cube just because you don't have to cube a binomial a lot. So what I showed you in your notes is just a binomial cubed is really just the binomial squared times itself. And then we use our shortcut for x plus 1 squared. That's a binomial squared. And we square the first term, multiply and double to get the 2x, and square the last term to get the 1. And then we bring down the x plus 1, and then we just multiply the problem out from there. X squared times x gives you x cubed, x squared times 1 gives you x squared, 2x times x gives you 2x squared, 2x times 1 gives you 2x, 1 times x gives you x, 1 times 1 gives you 1, combined like terms. Then I think you can just look through my work for 61 and 65. Same thing with 69, 75, and 81. I think you should be able to follow my work. If you have trouble with something, ask somebody in your group. All right, the classwork for today. This is going to be a little bit harder than what you did for homework. Still going to be the same concepts, but it's kind of like the problems just have sometimes, like this one particular 83 kind of has like two problems in one. you've got two binomials that are squared, and then you got the subtraction sign in between. So we know order of operations, say we've got to do the exponents before we can subtract. So what we're going to do here is we're going to do square double square on the first binomial. So we're going to use our shortcut here. So 3x squared is 9x squared. Bring down my sign. Multiply these two terms together. That gives me 12xy and double that. So if I do 2 times 12xy, that's going to give me 24xy. And then I'm going to square the last term. That's going to give me plus 6y squared. And I'm going to keep that in parentheses because I'm subtracting. And then I'm going to square this second binomial by doing the shortcut, square double square. 3x squared is 9x squared. Bring down my sign. Multiply these two together. 12xy, double that. That's 24xy. Square the negative 4. Negative 4y times negative 4y is positive 16y squared. Then we're subtracting, so we can drop the first set of parentheses. And the second set of parentheses is what we're subtracting. So it's like we're distributing a negative 1, or all the signs in the parentheses that we're subtracting have to change. So end up with a negative 9x squared, a positive 24xy, and a negative 16y squared. And then I just come back and combine like terms. So my 9x squareds are going to cancel. The 24xy's are going to combine to be 48xy, and the 16y's are going to cancel. So cancel, 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 cancel. That should be your answer. All right, 87 is a binomial times a binomial times a binomial. So when you're multiplying three binomials together, you can't multiply all three at the same time. So what you're going to do is you're just going to choose 2 to multiply together. Now I'm going to choose, if these were out of order, I could change the order because the order that we multiply doesn't matter. And I would always want to try to multiply these two binomials together first because they're actually what we call conjugates. Very similar to what you rationalize the denominator with if you have a radical in the denominator. They're the same exact binomials except the signs are different. So when we multiply conjugates together, the two middle terms are always going to cancel. So we get 4x squared minus 10x plus 10x minus 25. Keep that in parentheses. Bring down that third binomial. So the 10x's are going to cancel. And then I'm left with 4x squared minus 25 times 4x squared plus 25. So now we actually have another pair of binomials that are exactly the same except for their signs. So again, these are called conjugates. So the two middle terms, once we FOIL this out, should cancel. So 4x squared times 4x squared is 16x to the fourth. And then I get plus 100x squared minus 100x squared minus 625. So these two middle terms cancel out, just like we knew they would. And our final answer is 16x to the fourth minus 625. In 89, we're dividing, so we're going to use our quotient rule. We have 2x minus 7 on the top and a 2x minus 7 on the bottom. One's raised to a power of 5, the other is raised to a power of 3. So actually the shortcut here is to take the smaller exponent, move it up, and subtract it. So that's going to leave us with 2x minus 7 to the second power. All right. Definitely, there's a long way to do this. You could actually multiply 2x minus 7 times itself 5 times on the top, 2x minus 7 times itself 3 times on the bottom, and that would just be horrible. So we definitely want to use our quotient rule here where we're subtracting our exponents. Now we have a binomial squared. If you want to do 2x minus 7 times 2x minus 7 and work that out the long way, that's up to you. I'm going to use the shortcut, which is square double square. So take the first term, 2x, and square it. That's 4x squared. Bring down the sign. Multiply the two terms together. That's 14x. Double 14x, and that's 28x. Square the negative 7, and that's plus 49. You have the answer. Square, double, square. All right, if I would have been in class today, we would have done 91, but nothing like 91 is going to be on your quiz, so we're just going to omit 91. We're going to go straight to 93. 93 is giving you a box which has a length, a width, and a height, and they're asking you what is the volume of the box. So that would be how much could fill the box. Volume is like if you were to pour water in it, the amount of water that would go in the box would be the volume, or if you were to pour sand in it, the amount of sand that goes in the box is the volume. So you find volume by multiplying the length of the box times the width of the box times the height of the box. So it really doesn't matter what order we go in because we're multiplying, and remember the order that we multiply doesn't matter. So I would like the x to come first, just because that's going to make my multiplying a little bit easier. And then it doesn't really matter which dimension you let be in the second and the third spot. Doesn't really matter that the x comes first, except that's just kind of how I prefer it. So we could put the other two dimensions in either one of these spaces. And then again, if you're multiplying three things together, it's really hard to multiply all three at the same time. So I would suggest that you do two at a time. So I'm not foiling here because I'm not multiplying a binomial times a binomial, so I'm just distributing. So it gives me 8x minus 2x squared. Bring down that last dimension of 10 minus 2x. And now I have a binomial times a binomial. So I'm going to have to FOIL this out. So I'm going to get 80x minus 16x squared minus 20x squared plus 4x cubed. Combine like terms. Now, in higher level math, they really like the answers to be in what they consider standard form, which is the highest exponent first. This is probably how the book is going to state the answer. You don't necessarily have to write it in this form unless the directions are specific. But there's a lot of things that we do in math, and if your polynomial's in standard form, it's just ready to go. It's like you're just ready to go and do any other thing that we may have to do with it. So this is actually our final answer. This is volume, so we might want to say, I don't think it tells us, we're not measuring in centimeters or inches. It's not really telling us. If we were, this is volume, so it would be cubic units. So we're just going to say units cubed here. So if we were measuring in centimeters, we would write centimeters cubed because we're doing three things multiplied together. So a centimeter times a centimeter times a centimeter would be centimeters cubed. They're not actually giving us a specific unit, so we'll just write units cubed there. Okay, they are asking us to write a polynomial expressing the shaded region. Expressing the shaded region. So what we really have here is we have a big rectangle, and then we have a little rectangle being cut out of it. I'm going to use my little shader tool here. So what's happening is this rectangle is being cut out of the big rectangle. Okay, so the area of a rectangle, let me remind you, is base times the height. So to find the area of the purple shaded region with the hole cut out in the middle where I have my little yellow lines, you're going to find the area of the big rectangle. So the area of the big rectangle would be x plus 9 times x plus 3. That's the area of the big rectangle. And because we're cutting out the little rectangle, we're taking it away. So because we're taking it away, we have to subtract the area of the little rectangle. And the area of the little rectangle, the rectangle that's cut out, the one that's not shaded, has a base of x plus 5 and a height of x plus 1. So our polynomial is going to be x plus 9 times x plus 3, the area of the big rectangle, minus the area of the little rectangle, which would be x plus 5 times x plus 1. So order of operations, so we have to multiply before we can subtract. So we would FOIL out these first two binomials. Keep that answer in parentheses, bring down your subtract, FOIL out the second pair of binomials. Keep those in parentheses, combine like terms. Because you are subtracting the second set of parentheses, you're going to end up having to distribute a negative 1. So let's do this real quick. You're going to get a 6x there. So if you distribute a negative 1, you're going to get negative x squared, negative 6x, negative 5. Negative x squared minus 6x minus 5, and then you'll combine like terms. X squareds are going to cancel. X terms are going to combine to be 6x. Constant terms are going to combine to be 22. So this is area, and area is in square units. So we would write units squared. Again, if we were measuring centimeters or inches, we would say inches squared. All right, hopefully this helps. We've got one more problem. What is a polynomial in x? What is a polynomial in x? So, for example, you've been dealing with polynomials in x. The last example, the final answer was a polynomial in x, but I'll just make something up. So, 3x squared plus 5x minus 7 is a polynomial in x because the only variable that's in the polynomial is the variable x. So a polynomial in x would not have any other variables in it other than just x. All right, so to show you a polynomial that would not be in x, you would have something like 2x squared y plus xy minus 7y plus 5. So this would not be a polynomial in x because it has another variable in it other than x, the y. So this would not be a polynomial in x. So it's asking you to write out in words what is a polynomial in x, and you would just say something like a polynomial in x you can just say has one or more terms. With only the variable x. A polynomial in x has one or more terms with only the variable x. All right, once you finish your classwork, remember that you do have a review. It is a review for Friday's quiz, and it's in the back of section P. I believe it's page... I'm looking. It's on page 86. So the review for the quiz tomorrow is on page 86. And you're doing 1 through 31 all. You're also making sure that you go back and study all your notes. Hopefully you've already began to do that. I think I have the wrong page here. Just 1 second. Oh, I do have the wrong page here. Page 61. Page 61 is a mid-chapter checkpoint, 1 through 31 all. And you do have the even answers to this textbook in the back of the book. When it does the mid-chapter and the end of the chapter reviews, it has all of the answers, evens and odds. All right, have a good day. See ya.